Hello students, welcome to All Force e-learning channel. This is K. Nageshwar Rao, physics faculty. We are in session number 34. Yesterday we have derived all kinematic equations. So let us quickly recollect what has been completed yesterday. What we have done, we have derived 5 kinematic equations. One equation is this one. What is this? V is equal to u plus at. V is equal to u plus at. This can be expressed in vector form like this. V bar is equal to u bar plus a bar into t. That's how in vector form it can be written. Okay. And the second equation is this one. S is equal to ut plus half at square. And the same equation can be expressed in vector form like this. S bar is equal to u bar t plus half a bar t square. Okay. The other equation is this one. What is this? V square minus u square is equal to 2as. The same equation can be expressed in vector form like this. V bar dot V bar minus u bar dot u bar is equal to 2a bar dot s bar. Like that it can be expressed, or simply you can write it as V square minus u square is equal to 2 into a bar dot s bar. Like that also you can express. Okay, so these are arithmetic equations, and additionally we have seen this equation also. What is this? Sn is equal to u plus a into n minus half, where Sn is what? Distance covered in nth second, isn't it? The other equation is this one. VAVG, average velocity, is equal to V plus U by 2. Okay, so these are the equations that we have derived yesterday, and we'll try to solve few problems based on these equations. Okay, let us proceed. So, okay students, let us have a look at this question. A car moving with constant acceleration covers the distance between 2 points 180 meter apart in 6 seconds. Its speed as it passes the second point is 45 meter per second. What is its acceleration and its speed at the first point? At the first point. So, see, at the first point or at the last point, the acceleration will be same, because it was said that the car is moving with constant acceleration, right? So, here we have to find out the velocity of the car at the first point. I will take this as first point. Okay, I will call this as A, and let this be last point B. Okay, so car has traveled from point A to point B. When it is crossing this point B, what was its velocity? Its velocity is given as 45 meter per second. 45 meter per second. And the distance of separation between these 2 points is given as, how much is that? 180 meters. These 2 points are separated by 180 meters distance. See children, whenever any question is given in kinematic, related to kinematic equations in one-dimensional motion chapter, students frequently they get confused with the usage of these kinematic equations. Immediately one question will arise, sir, what equation should be used to solve this question? We have 5 equations, right? S is equal to ut plus half at square, V is equal to u plus at, V square minus u square is equal to 2as, Sn is equal to u plus a into n minus half, and VAVG, average velocity, is equal to V plus u by 2. Okay, so which equation should be used to solve the problem? Remember students, based on the data given in the question, you have to choose appropriate equation. Okay, it's not like, if I wanted to go with V square minus u square is equal to 2as. Okay, here time related data is given. How much is that? 6 seconds. Distance of separation is given between the 2 points. Final velocity is given. So what are the given parameters here? V is equal to what? 45 meter per second, and S is given as 180 meter. Time of journey between these 2 points is given as 6 seconds. Okay, isn't it? So if you take V square minus u square is equal to 2as, okay, so we don't know A, S is given, we don't know V, so 2 unknowns are there. Okay, so all that you need to do is, based on the given data, you have to choose appropriate equation. I'll take this V is equal to u plus at equation. Okay, V is equal to u plus at equation. Here u and a both are unknowns, but anyways 2 unknowns are there. I'll try to write 2 equations corresponding to this data. I'll be able to solve them. So this final velocity is how much? 45 meter per second. U, it's unknown. Initial velocity, A is unknown. T is given as 6. So 6a. Let us take it as equation number 1. Okay. Next I will take, S is equal to ut plus half at square. What is that? S is equal to ut plus half at square. Let us consider this equation. Here S is given, how much is that? 180 meters. U is unknown, 6 seconds. Time is 6 seconds. So 6u plus A is unknown, T is 6. 6 square. How much is that? 36. 36 by 2, it's 18. So 18a. let us take it as equation number 2. From equation 1, what you can write for u can be replaced with 45 minus 6a, and in this expression I will replace u with 45 minus 6a. Let us see what we will be getting. 180 is equal to, this is where I am replacing u. Okay, 45 minus 6a. With this 45 minus 6a I will replace u. 6 into 45 minus 6a plus 18a. How much is this? 0. 27, 270 minus 36a plus 18a. 270 minus, how much you will get? Minus 18a, 180. So 18a is equal to, what you will get? 270 minus 180. 270 minus 180 is 90. So a is equal to 90 by 18, and how much you will get? 18 jar 90, right? So a is equal to 5 meter per second square. This is what you will be getting for acceleration. So the constant acceleration, whatever he is talking about in the question, that is how much? 5 meter per second square. Let us find out u. Okay, from this equation, u can be written as 45 minus 6 into 5. 6 5s are 30. 45 minus 30 will give us 15. So initial velocity is how much? 15 meter per second, and acceleration is how much? 5 meter per second square. Let us try to solve the same question in the other possible way. Here, total distance of separation between the 2 points is given. How much is that? 180 meter. Okay. Since VAVG is equal to u plus v by 2, and here VAVG can be written as total distance by time, u plus v by 2. Total distance is how much? 180, and the t is 6 seconds, right? 6 is equal to u plus final velocity is given as 45 by 2. So what you will get here? 30, 60 is equal to u plus 45. Therefore u is equal to 60 minus 45 is equal to 15 meters per second. This is what we are getting, isn't it? So very simply you can calculate like this: initial velocity. Once initial velocity is known, you can make use of this equation or any other equation, this equation, and you can find out a value, and a value is how much here? 5 meter per second square. So when you expose yourselves to several models, you will eventually come to know how to choose appropriate equation to solve the given problem in kinematics. Okay, beta? Right. I'll try to solve one more problem now. Okay. So now let us see this second question. What is this? A bus starts from rest with a constant acceleration 5 meter per second square. At the same time, a car traveling with a constant velocity 50 meter per second overtakes and passes the bus. How fast is the bus traveling when they are side by side? Here, children, the bus has started from rest. Starting from rest in the sense, remember, you have to take initial velocity as 0. Okay, so it has started from rest and it has maintained a constant acceleration 5 meter per second square. So when it is starting from rest, at the same time, a car has just passed by, okay, just beside the bus. And the car is moving with a constant velocity, how much? 50 meter per second. Car is maintaining constant velocity, 50 meter per second. But bus is maintaining constant acceleration. If it is maintaining constant acceleration, gradually its velocity increases. Definitely at some point of time, what happens? The bus overtakes the car, because car is maintaining constant velocity. Acceleration is 0 for car, isn't it? So it is maintaining the same velocity, whereas bus's velocity is gradually increasing. It is increasing. So at some point of time, certainly the bus overtakes the car. So when both are side by side, when bus is overtaking the car, they will be side by side, right? At that time, he is asking us to find out velocity of the bus. It's quite easy. Let us find out. Imagine this is the starting point. This is where the bus might have traveled, might have started. Okay, its initial velocity is 0, and what has the acceleration of the bus? 5 meter per second square. At the same time, a car is also is traveling just from the side of the bus, and with what constant velocity it is moving? It is moving with a constant velocity 50 meter per second. Okay, let us say at somewhere here they met, they are side by side, and they have covered, let us assume that they have covered a distance equal to s. Okay, and we don't know at what time they are side by side. Okay, after how much time they are side by side and how much distance they have covered. Let us first try to find out how much distance they have covered. I'll make use of this one because distance covered by the car and distance covered by the bus in this case is same, because after some time they are at this point, isn't it? Both are side by side. So distance traveled by both these, bus and car, they are same. Okay, so for bus, I'll write S as ut plus half at square. Since bus has started from rest position, u is 0, initial velocity is 0, so this term vanishes. Half into a is given as 5 meter per second square. T we don't know, so s is equal to what? Half into 5 t square. And for car, the distance of what a journey, the distance covered by the car is also same. S is equal to, I'll write it as, since it is maintaining a constant velocity, you can write this as simply ut. Okay, and how much is the velocity maintained by the car? 50 into t. Okay, so both these two distances are same, LHSs are same. I will equate these two RHS, then I will be able to find out what this t is. If I am able to find out what this t is, I will be able to find out how much velocity this bus is maintaining by the at the time of overtaking the car. Okay, so let us find out. 50 t is equal to half 5 t square. Here t gets cancelled, therefore t is equal to 50 into 2 by 5. So finally what you will get? 10, 20, so 20 seconds. So after a time equal to 20 seconds, bus overtakes the car. That's what we are seeing here, isn't it? Now, since v is equal to u plus at, I used this equation because I wanted to find out the final velocity of the bus when it is overtaking the car, when it is just beside the car. So v is equal to initial velocity, it has started from rest position, so it's 0 plus a is how much? It was said that a is 5 meter per second square, and what about the time? 20 seconds. Okay, so it means I am calculating velocity acquired by the bus after a time equal to 20 seconds when it has started from rest, maintaining a constant acceleration 5. So into 20, so what you will get? 100 meters per second. So the velocity of the bus when it is overtaking the car is how much? 100 meter per second. So that's how you have to find out. So let us solve one more problem. Okay, students, let us try to understand this third one. Let us try to solve this one. What is this? A bus starts from rest to move with an acceleration of 1 meter per second square. A man who is 48 meter behind the bus runs with constant velocity of 10 meter per second to catch it. In how much time he will catch the bus? This is the question. So what was the situation? A bus is there and it has started from rest and it is maintaining a constant acceleration of 1 meter per second square, and a person is there behind the bus at a distance of 48 meter. Now that person's intention is he wanted to catch the bus, so he has to run. So with what velocity, with what constant velocity he is running behind the bus? 10 meter per second. So definitely, if he will be able to catch the bus. So after how much time he will catch the bus? That's what we are supposed to find out. So the time after which he will catch the bus. So that's what we are supposed to find out. Let us imagine that there is a bus somewhere here. Okay, it is moving along this direction with an acceleration 1 meter per second square. Initial velocity is 0. Okay, let us say somewhere here the person is standing on the road at a distance equal to 48 meters behind the bus, isn't it? So the moment when he has seen the bus starting from rest with an acceleration 1 meter per second square, he started running with a constant velocity equal to 10 meter per second. So we have to find out the time after which he will catch the bus. Let us say the bus has covered a distance equal to s in a time t. First of all, I will assume that the time after which he reaches the bus is equal to t. So in a time t, this bus will cover some distance. I will assume that the distance as s. In the same time t, how much distance this person has to cover? He has to cover a distance equal to how much? 48 plus s. 48 plus s. Okay. So let us first write the equation for a distance covered by this bus. For bus, how much is this? S is equal to ut plus half at square. Since it has started from rest, I'll this term ut term vanishes and you are left with half into a is how much? 1 meter per second square into t square. So it's equal to t square by 2. Okay, and for the person, what is the equation? S plus 48. In the same time, how much is the distance covered by this man? 48 plus S, or S plus 48 equal to, he is maintaining a constant velocity, right? What is that constant velocity? U, and this velocity U is given as 10 meter per second, so 10 t. Okay, and this S can be replaced with t square by 2. I'll take this as equation number 1, this as equation number 2. From 1 and 2, what you can write? T square by 2 plus 48 is equal to 10t, or t square plus 96 20t, isn't it? Now let us shuffle this equation a little bit. T square minus 20t plus 96. This is a quadratic equation, right? Now I'll split the middle term. T square, what you will get? Minus 12t minus 8t plus 96 equal to 0. This is how it can be written. So t of t minus 12 minus 8 into t minus 12. That's how equation can be written. Therefore, t is equal to 8 and t is equal to 12. So after a time equal to 8 seconds, he will be able to catch the bus. What this 12 is? After a time equal to 12 seconds also, he will be able to catch the bus. I want you to understand this point. What answer you have to consider, whether it is 8 or 12. You have to consider this one only, because after 8 seconds he will catch the bus. He won't be running on the ground, right? This 12 seconds, you can understand this situation like this. After 9 seconds or 10 seconds, he might have already crossed the bus. Somewhere here he has already crossed the bus and he is running. And by the time, since bus is maintaining a constant acceleration, at some point of time again bus and the person will be just side by side. At that time he will be able to again board into the bus. So that time is what? 12 seconds. So there are two possibilities for this person to board the bus. Okay, after time equal to 8 seconds exactly, here he can catch the bus, or he can run little bit ahead, and after a time equal to 12 seconds also, bus and person will be just side by side, and again he will be able to catch the bus. Okay, so the answer for this question will be taken as 8 seconds. Okay, so that is how you have to handle the question. Okay, so let us solve one more problem. Now let us consider this problem, fourth one. What was given in the question? A bus accelerates from rest at a constant rate alpha for some time. Constant rate in the sense here acceleration. He is talking about acceleration. Alpha is what? Acceleration. It is maintaining a uniform acceleration for some time, after which it decelerates at a constant rate. Again it is undergoing what? After some time, deceleration. Gradually the velocity is decreasing, and even that is also constant. So it is undergoing for a while a uniform acceleration, and later it is undergoing uniform retardation. Okay, and at what rate this is going on? Beta. Okay, so the retardation value is beta, acceleration is alpha. So let me read again. A bus accelerates from rest at a constant rate alpha for some time, after which it decelerates at a constant rate beta to come to rest. If the total time elapsed is t seconds, then evaluate following parameters from the given graph. So this is the graph given. So what was said? Total time elapsed when the body has traveled, when it has finished the complete journey, how much time it has taken? T time. Okay, so initially there is acceleration. Okay, velocity is gradually increasing and increasing. It is going to set a maximum value of velocity. Okay, I'll take this as V maximum. Okay, at what rate? At a rate equal to alpha. And after this, what has happened? It started undergoing deceleration. At what rate? At a rate equal to beta. Okay, and I'm taking the time slot during which it has maintained a constant acceleration is taken as t1. The time slot during which it has maintained a constant retardation, I'm taking that time as t2. And here t1 plus t2, total time elapsed is how much? T, isn't it? So what we have to find out? We have to find out the maximum velocity achieved, the total distance traveled, and the average velocity. So let us try to find out these three parameters from the given graph. Okay, so I'll make use of physical significances of velocity time graph. I would like to recollect now what we have discussed. One is the slope of velocity time graph gives us acceleration. The second one is area under velocity time graph gives us total displacement, isn't it? So let me first make use of one physical significance of velocity time graph. I'll find out slope here. Slope of OA, this line's slope, is nothing but alpha, right? Is nothing but alpha, isn't it? And this alpha can be written as what term? Slope is what? Tan theta. If you imagine theta here, opposite side by adjacent side. And what is opposite side here? V maximum. So V maximum divided by what is the adjacent side here? T1. So from here, this T1 can be written as V maximum by alpha, isn't it? Now similarly, slope of AB, this one gives us what? It gives us beta. And even this is also written as opposite side, V maximum by how much is the time? T2. So from here, this T2 can be written as V maximum by beta, isn't it? If I add this T1 and T2, what I will get? I will get total time T, isn't it? Therefore, T1 plus T2 is equal to, what is T1? V maximum by alpha plus, what is T2? V maximum by beta. T1 plus T2 is T. So you can take out V maximum common. So then you will have alpha plus beta by alpha beta. Therefore, V maximum velocity attained by the bus is equal to how much? Alpha beta by alpha plus beta into T. So this is the expression for the maximum velocity achieved by the bus. Now let us have a look at this total distance traveled. Total distance traveled is nothing but the area under this graph, right? So total distance traveled is equal to, okay, is equal to, I'll take this total distance traveled as S, is equal to area under the graph. This is another physical significance of velocity time graph. Area under the graph. Area under the graph. What is the area of triangle? Half into base into height. What is the base here? T1 plus T2. T1 plus T2. And what is the height? Maximum velocity. And this is T. T1 plus T2 is total time elapsed. And V maximum, just now we have derived equation. Alpha beta by alpha plus beta into T. So T, I will have T square. So half alpha beta by alpha plus beta into T square. So this is the expression for total distance traveled. Okay. Now what is the last one? Average velocity. How this average velocity can be calculated? VAVG is equal to total distance by total time taken. What is the total distance here? This is the total distance traveled by the body, isn't it? Distance or displacement. This bus is traveling along straight line. Okay. Okay. So how much is that? Half alpha beta by alpha plus beta into T square divided by total time. Total time elapsed is how much? T. So when you divide with T, T gets cancelled, and finally you are left with half into alpha beta by alpha plus beta into T. So this is the expression for average velocity. So that's how you can find out maximum velocity, total distance traveled, and average velocity. Okay. So I hope you have understood, you have realized the importance of physical significances of graphs. Okay. There will be problems like this, okay, where you need to make use of physical significances of graph to solve the questions. Okay. So now let us continue with one small discussion. Okay. There are applications of these kinematic equations. We describe situations, and in those situations we look for various possibilities, and in each and every possibility we use these kinematic equations to draw several conclusions. That's what we will be doing. Okay. So today I'll go with little discussion related to what applications of these kinematic equations. Okay. Further, how these kinematic equations can be shuffled and molded, and how these things can be applied for various situations. Okay. So students, we know that distance traveled in nth second, how it is expressed? It is expressed as Sn. Sn is equal to what? U plus A into n minus half. U plus A into n minus half. What if body starts from rest. That implies u equal to 0. Therefore, Sn is equal to a into n minus half, isn't it? So here I'll assume that n is equal to 1, 2, 3 and so on. Okay, so let me find out S1. S1 is what? The distance traveled in the first second is equal to a into, let the acceleration of the body is constant, then only we will be able to use this equation. Okay, a into 1 minus 1 by 2, which is equal to a by 2. S2 is equal to, S2 in the sense distance traveled by the body in the second. Okay, a into 2 minus 1 by 2, and equal to what? 2. So what you will get? 4, 3 by 2. So 3a by 2. Similarly, S3, distance traveled in the third second, a into 3 minus 1 by 2. What you will get? 5a by 2, isn't it? And so on. Like that, you can keep on writing several equations. When you take ratio between all these distances traveled in consecutive seconds, in the first second, in the second second, in the third second. If you take ratio between all those distances, what you will get? S1 is to, S2 is to, S3 is to, and so on. You will get here 2, 2, 2, it gets cancelled, and a also gets cancelled. Let me write here, a by 2 is to, 3a by 2 is to, 5a by 2 is to, and so on. A gets cancelled, 2 gets cancelled. You are left with 1 is to, 3 is to, 5 is to, and so on. So you have to remember this one. So ratio between the consecutive distances or distances traveled in consecutive seconds is equal to what? 1 is to 3 is to 5, provided if the body starts from rest. If body starts from rest, if its initial velocity is 0. What happens in case of what? Distances traveled in 1 second, 2 seconds, 3 seconds, 4 seconds. Okay. Its counterpart is S equal to ut plus half at square. So this equation gives us total distance covered by the body in t seconds. So in the first second, let us say it has traveled a distance equal to half at square. Here also body starts from rest, so initial velocity is 0. So if u is 0, from this equation this term vanishes. So S1 dash is what? Distance traveled in the first second or in 1 second. Distance traveled in 1 second is equal to half at square, and you can replace t with 1 because we are talking about distance traveled in 1 second. So 1 square, or simply a by 2. Distance traveled in 2 seconds. I hope all of you are able to identify the difference. Here I am talking about distance traveled in 2 seconds, and here distance traveled in second. Okay, and here this is distance traveled in 2 seconds, which is equal to half a 2 square. You will have 2a, isn't it? Distance traveled in 3 seconds, and here what is this? Distance traveled in third second. Okay, so distance traveled in 3 seconds is what? Half a 3 square. What you will get? 9a by 2. Okay, and so on. So let us take ratio between these things. S1 dash is to, S2 dash is to, S3 dash is to, and so on, is equal to a by 2 is to 2a by, you can take like this, 4a by 2. Okay, the actuality of the equation is not disturbed, it is intact. When you divide, you will get back this 2a is to 9a by 2 is to, and so on. A gets cancelled, 2 gets cancelled, and you are left with 1 is to 4 is to 9 is to, and so on. This can be written as 1 square is to 2 square is to 3 square is to, and so on. That's how you can write. I hope you are able to identify the difference between these two. Here you are having odd numbers, 1 is to 3 is to 5. What these distances are? These are distances traveled by the body in consecutive seconds. And here distance traveled in 1 second, distance traveled in 2 seconds, distance traveled in 3 seconds. Like that, if you take distances and if you take the ratio, this is what you are getting: 1 square, 2 square, 3 square. Okay, so this is one small point that you should understand, and let me consider one more point. Okay, let me erase this. So let us assume that body is starting from rest. If it starts from rest, this equation Sn becomes a into n minus 1 by 2. Similarly, I'll consider this equation S is equal to ut plus half at square. Okay, So here, if the body is starting from rest, again this term vanishes. You will have S is equal to half at square. Okay, half at square. Just for convenience, I will replace here also t with n. It means distance traveled by the body in n seconds, not in nth second. N seconds. N square. Yeah, this is basic equation, so you can keep it like that. Now take the ratio between these two. What you will get? Sn by s, a into n minus 1 by 2, and here what you will have? A n square by 2. A gets cancelled, and you will have 2 by n square into 2n minus 1 by 2, and 2 gets cancelled, and finally the ratio between Sn and S is equal to what? 2n minus 1 by n square. Like this you can have ratio between Sn and S. Here Sn is what? A distance travelled in nth second, and S is what? Distance travelled in n seconds. Now the question is, why is it necessary to have these kind of relations between all these things? See, children will have questions, based on such kind of relations. By this time, I think you might have realized whatever 5 kinematic equations I gave you, you can make use of those kinematic equations to solve, problems, whatever problems we have discussed now. And in kinematics or in one-dimensional motion, you can expect question of any kind. Like there is a vast possibility to design several questions. Okay, so whatever question it might be, all that you need to know is how to make use of these kinematic equations to handle the question. In the question, he will give us entire information. First, try to identify what information is given. Once you are having the data with you, you will be able to choose appropriate equation and you can proceed. And it's quite easy. Okay, sometimes you will have quadratic equation, and you all know how to handle the quadratic equation. If the body starts from rest, you have to take initial velocity as 0. Okay, these are few points that you should remember, and we'll continue in the next session with some other applications of these kinematic equations. Okay, thank you, students.